Okay, so today we're going to talk about chemical bonding and why it's so important. So we have to keep in the back of our mind the periodic table going because all of that stuff still plays a role in chemical bonding and is still very important. So two types of bonds are ionic and covalent. Okay, so we're going to go through each type and we're going to just start with an overall view of bonding. So bonding is the way atoms are attracted to each other and they form all of the molecules and compounds that make up every single thing that you can think of. So even just looking at yourself, really all you are a bunch of chemicals bonded together. That's it. So without chemical bonds, you would not be sitting there. You would not be using your computer. The entire Earth really would not exist. So chemical bonds are extremely important. Another thing that's very important is the number 8. So we're going to go through, just keep in the back of your mind, 8 is the magic number. Okay. So we know that noble gases are very stable compounds. They do not react with others. They're in the far right group all the way down. They're in group 8A. So that tells us that they have 8 valence electrons, which is why the number 8 is so important. The only exception we should know is helium. Helium has 2, and that is how many it needs to be stable, because it fills that first ring. Elements that are not completely filled are kind of like jealous of the noble gases. They want to be like them. They want to be stable. So what they do is they go through reactions and work with others to really get them to that point. So they want to fill up so that they can be similar to the noble gases. They want to get that 8. First way they do that would be ionic bonds. So to achieve stable electron configurations, some elements actually transfer electrons between atoms. So one gives and one takes. That's called an ionic bond. So if an atom gains or loses electrons, the protons and electrons are now not equal. Okay? Because of that, there's going to have a charge, either positive or negative, on that atom. When there's a positive or negative charge, we call it an anion. If the element gives up electrons, it now has a positive charge because there are more protons, more positive charges, and we call that a cation. The way you can remember is that T looks like a plus sign. Cation, positive. When an element receives electrons, now it's going to have a negative charge because it has more negative, and we call that an anion. The way you can remember that is you could think anion stands for a negative ion. So that N gives you the hint that's negative. So again, gain, it's negative. Lose, it's positive. It's kind of a little bit backwards from what you would think, but just keep in mind those charges. Electrons are negative, protons are positive. That's the important thing. Now a charge is determined by how many are gained or lost. So if there are 2 that are gained, your charge is going to be 2 minus. And now you have 2 more negatives than positives. If it loses 2 electrons, it's going to be 2 plus because you have 2 more protons, 2 more positive charges than those negative to cancel out. So for an example, sodium, it has 11 protons and 11 electrons. If you look at the group, it's in group 1, so there's 1 valence electron. If that sodium atom loses an electron, its new charge is going to be plus 1. So it lost it, so it has more protons than electrons, so it's plus 1. That would make it a cation. Another example, chlorine has 17 protons and 17 electrons. Look in which group it's in 7A, so it has 7 valence electrons. If that rogue electron from sodium comes and joins chlorine, now it's going to have a charge of 1 minus, because it gained 1 electron. And that is any negative ion, so it's an anion. Opposites attract. So a particle with a positive charge is going to be attracted to a particle with a negative charge, and that is really what's going to hold them together. That chemical bond forms between them. That's the ionic bond. So it's the force that holds together cations and anions when one electron is given to another. So in that example that we just did, when that sodium gave that electron to the chlorine, it created an ionic bond, it created those charges, and they stick together pretty much. So this type of bond takes place between a metal and a non-metal always. Metals always give up electrons, making them cations, positive charges, and non-metals always take them, making them anions, negative charges. Ionization energy is the amount of energy that's needed to remove an electron. Okay, so basically what happens is that atom is going to absorb energy, and one of those electrons that's moving around on the outside is going to get higher and higher and higher in those energy levels until it gets so high and far away from that nucleus that it pops off and goes to another element. That's when we get a cation, because that atom gained so much energy that the electron was able to move to another element. So as we look across the periodic table, different elements have different ionization energies. So this column has the least amount of ionization energy, and this column has the most. So these are the hardest to make into cations. These are the easiest, with francium being the absolute easiest. Okay, so it increases as we go across the period and decreases as we go down. So francium, again, would be that easiest one to make into a cation. It's very easy, willing to give up its electron. Okay, so now chemical formula is a notation that shows what elements a compound contains and the ratio of those atoms. So if I talk about NaCl, which is table salt, sodium chloride, you can tell because there's just one Na, one Cl, there's one sodium ion and one chlorine ion. Okay, so if there's no numbers written next to them, it indicates that there's just one of them. If we look at this, the chemical formula for magnesium chloride. So what happens is magnesium is a metal, so it becomes a cation. So it gives up its electrons. Gives one to one chlorine atom and the other to the other chlorine atom. So those charges, magnesium lost 2, so it becomes 2 plus. Each chlorine atom gained 1, so it becomes 1 minus. So now we look at that, we have 1 magnesium and 2 chlorines. So we would write MgCl2. 1 magnesium, 2 chlorines. So that 2 tells us that there are 2 chlorine atoms in that compound. This is how you draw an ionic bond. So basically you have the Lewis structure with any extra or missing valence electrons. You put it in a bracket and put the charge. Okay. Crystal lattices. So even though we have a chemical formula and we can tell how many atoms there are, it doesn't tell us how they are arranged. So some compounds, each ion is attracted to all the other ions around it. And when it does that, it makes a very rigid framework. It makes like cubes. That repeating pattern forms a lattice. When solids are made up of a lattice structure, they're crystals. So an example of a crystal would be sodium chloride, NaCl, which is salt. So that's table salt you have on your table. I'm sure you have it at home. You look closely at salt, you can tell it's a crystal. So it's a crystal lattice because each of those ions is surrounded by 6 ions of the other element. So if you look right here, you can see that. It makes a nice cube. Very rigid, hard framework. The last type of bond that we have is a covalent bond, which occurs between nonmetals. So this has to have two nonmetals. When they join together, these two atoms actually share the electrons. That's a single bond. So they share two electrons, one single bond. One single bond, two electrons. The attractions between the shared electrons and the protons in the nucleus are what holds it all together. And when these units are formed, they're called molecules. Okay, a molecule is a neutral group of atoms that's joined together by one or more covalent bonds. And to make sure that it's neutral, you have to have the same number of protons and electrons. Okay? Same number of protons and electrons, because they cancel each other out. We know that's what makes it neutral. So here comes our other hydrogen. And see these two right here are being shared. They both want those two, so they just share them, which is what co means in covalent, sharing. So think of like a co-worker. You share the work. Covalent, they share the valence electrons. They share them, they're both happy, they're both full. So that's a covalent bond. And that's, again, one single bond with the two electrons. Last thing I want you to just write down is that we have different ways to represent a covalent bond. If you could make a drawing of these, that would be awesome. At least draw electron dot and structural formula, but you can just write about the space filling model and electron cloud model if you think they're a little bit difficult to draw. So electron dot, we show those valence electrons in that one single bond. There are those two. A structural formula, we use a line to represent a single bond. Space filling model, this is how we would assume the atoms are actually fused together and attached. The electron cloud model uses that generation of possible locations an electron could be to show where they overlap. Okay, so that's the last bit. We're going to go over more of this in class and practice. So if you have any questions, just come in with them tomorrow. If you need to go back, pause, go ahead, and have a good night.